subscribe to our YouTube channel, Joy Learning TV.
Once again, I come your way with a geography lesson. In fact, it's a Form 1 topic, I must say. And, although it's a Form 1 topic, but whether you are in Form 1, Form 2, or Form 3, you are being encouraged to study, okay? And, in fact, the geography associates, when I say associates, we have people who love geography, but then they didn't want to study geography in school, maybe for one or two reasons. So keep watching your favorite geography facilitator right here on Joy Learning, Boga Sam. In fact, I must say that just in case you need help for your ward when it comes to geography, I'm always available once there is live, okay? Or you come to the Achimota School and ask for Boga Sam. Or the best way, the quick way, is to get my contact number from my producer, and you will actually be given. Right, so let's quickly go. What is the topic for this session? Okay, the structure and composition of the Earth's atmosphere, part 2. And you attest to the fact that as we find ourselves on the surface of the Earth's crust, in fact, we find ourselves in the atmosphere. No two ways about that. And because the last time that we met, we talked about the atmosphere. We looked at the part 1, actually, okay? Where we said the atmosphere is a thin layer of gases that surrounds the Earth. Okay, and then we learned about the layers of the atmosphere. And I'm sure you have not forgotten them. Is that okay? And you remember that we made mention of the troposphere to be the first, also the lowest layer of the atmosphere, okay? And I even said that it has the name troposphere, as in, so I emphasize on the tropos. Tropos, in fact, it is a Greek word which means change. Tropos, change in Greek. And so why that name? Why change? Change because it is the troposphere that we have our weather which keeps what? Changing. The weather keeps changing in the troposphere. And for that matter, the name troposphere. Is that okay? So tropos, change. Good. Now, let's quickly look at our objectives and see whether we can look at the rest, also the remaining layers of the atmosphere, and then we bring down the curtain on the structure and composition of the atmosphere. And so explain the following. What are we to explain? We need to explain the stratosphere, okay, the mesosphere, the thermosphere. Is that all? Let's see whether we have more. Then we'll look at the exosphere and finally the ionosphere. Is that okay? Aha. And so let me bring a line here. I know why I'm bringing this line. I'll explain. So we have the stratosphere, the mesosphere, the thermosphere. Then we'll look at what the exosphere. Then we'll also try and then upgrade our understanding on ionosphere. Or in other words, teach you what ionosphere actually what means. That is if it is your first time that you are being exposed to this particular word topic, or this topic being introduced to you. Right, so when we talk after we talking about the troposphere, the next layer, as one ascends or as one assumes higher altitude from the surface of the Earth, is stratosphere. After the troposphere, is that okay? So after the troposphere, we have the stratosphere. Good. When I say this is the second layer, so the stratosphere is the second layer of the atmosphere. As one goes upwards. Is that okay? As you ascend, okay? The first layer, which of course we find ourselves in the troposphere. And after the troposphere, you get into the stratosphere, which is the second layer. And I know the question that you ask is that, do we have a clear-cut division in the entire atmosphere, indicating that this is troposphere and this one is stratosphere, mesosphere, thermosphere, and all that. I know some will be asking, okay? Don't forget that the divisions were actually done based on what? Temperature actually plays a key role. How the temperature behaves as one goes up. Is that okay? Just as I told you that when it comes to the troposphere, that one we have the weather which keeps what? Changing. And what can we also talk about about it as far as temperature is concerned? Quick one. Don't forget that I told you that as one moves up, the higher you go, the cooler it becomes. Is that okay? There is that inverse relationship between altitude and what? And temperature. So as you go up, the temperature rather decreases. And that is what we call the environmental lapse rate. The rate at which temperature changes as one goes up. Is that okay? The rate at which temperature changes. So I remember we talked about the normal lapse rate. Okay? I said the positive. Is that okay? We talked about all of them. So just in case you have forgotten about them, then you must visit the previous lesson. So that doesn't take much time of ours as far as this session is concerned. So the stratosphere is the second layer of the atmosphere as one goes upward, or say goes upwards. No, it extends from the tropopause. And when we talk of the tropopause, what is it? You know, the pause. I remember teaching you the other time that the upper limits of the layers, okay, the upper limits of the layers are being denoted by what? Pause. So when you hear of tropopause, it means that is the upper limits of the troposphere. That is the transition from the troposphere to the next layer, which is the stratosphere. So the upper limit of the troposphere, as in the boundary between the troposphere and that of the stratosphere, that is what we call the tropopause. Is that okay? Good. So we are saying that the stratosphere extends from the tropopause to about 50 kilometers, where its boundary. Let me take it again. It extends from the tropopause to about 50 kilometers, where its boundaries, that is the stratopause, is what is found. Is that okay? Good. It is a very dry air, and it contains little water vapor. Don't forget once again that these gases that form the atmosphere, nitrogen alone has about 78%. Nitrogen alone is 78%, I must say. Then oxygen 21%, and then we have these trace gases. And then the common trace gas that you get in the atmosphere is that of the argon. Is that okay? Which we call the noble gas. Now, apart from that, we have water vapor and the rest. You know, in the troposphere alone, we have about 99% of the water vapor. When you take the entire atmosphere, the troposphere alone contains 99%. Is that okay? And when it comes to the mass of the atmosphere, the mass, is that okay? The troposphere alone is about 75%, as I did teach you in the previous lesson. So apart from the gases, we have other ones like the water vapor, we have smoke and all that, and dust also being in the atmosphere. Is that okay? But here, talking of the stratosphere, we don't have smoke there, okay? So it is a very dry air and contains little water vapor. Little. So it means the 1% left, we have, out of the 1%, we have parts being the stratosphere. And as a result, few clouds are found in this layer. I repeat, few clouds are found in the stratosphere. And almost all clouds occur in the lower, more humid troposphere, as I told you early on. So when it comes to the atmospheric weather conditions, they are actually found in the troposphere. Is that okay? They are found in the troposphere. Good. Now, That is to say that virtually there are no clouds, dust, and water vapor in the atmosphere. I used the word virtually. That is how come I've underlined it very well, virtually. So depending on what I've said already, we said that the amount of water vapor in the stratosphere is just scanty, it's just a few one. Is that okay? It's not plenty, or it's kind of not many. I don't even know which of the words to use. Is that okay? So more or less, it's like in the stratosphere, we don't have water vapor there, we don't have clouds there, because percentage-wise, it's less than 1. Is that okay? So virtually no clouds, dust, or water vapor in the stratosphere. Now listen to this. Aircrafts normally operate within this layer. Did you hear that? Aircrafts normally operate within this layer. Why do you think that aircrafts normally operate within the stratosphere? The previous sentence. Okay. Due to the lack of vertical convection in the stratosphere, materials that get into it can stay there for long times. And an example is the very important ozone. Okay? Ozone. But just before I explain the ozone, let me talk about why the aircrafts normally operate within the stratosphere. I've already established the fact that, or we've learned that, virtually we have no clouds in the stratosphere or no water vapor in the stratosphere. So what it means is that if the pilot should go up beyond that 20 kilometers and move into the stratosphere, is that okay? What it means is that they will not face kind of thick clouds over there. Or virtually they will not face any cloud over there. And so the crafts, also the plane, can move smoothly. And the pilot, just like the drivers, or say the motorists, they want to dodge potholes. In the same way, the pilots also want to avoid clouds, especially the thick ones. Because once the plane gets into the cloud, it obscures. One, it obscures visibility. And the second aspect to it is that it vibrates the plane, it shakes it. So just like you being in a car on the surface of the earth, and then the car runs into a pothole, and then it's like the car shakes. And especially if you're at the back, it's, hey, driver, my waist. And the craft too, the planes too, they also want to avoid what? The clouds. Is that okay? Good. Now, we are saying that the ozone stays in the stratosphere for long. It's one of the materials that we consider it stays in the stratosphere for long. All because there's lack of vertical convection. Is that okay? There's lack of vertical when we talk of convection, a situation whereby we have the warmer air going up and then the cold one being down. Is that okay? As in transmission of heat. But in this heat, we have the warmer one, as in the warmer air on top, and then the cold one down. And when we talk of the ozone, ozone is also a gas. So you have ozone layer. Ozone is a gas. And ozone falls, in fact, it forms parts of the 1% of these trace gases. Is that okay? So which can be found between 25 kilometers and 35 kilometers. So what does this ozone do? What does this gas do? Okay? Let's go. The ozone layer helps protect us from UV rays. In other words, ultraviolet radiation, UV, from the sun. Okay? And when we talk of the ultraviolet radiation, what is it? Okay? In simple terms, without this ozone, okay, we'll be having sunburns on our skins. Okay, that is what even causes the wrinkles on our faces, the wrinkles of our skin. Is that okay? And so it is this ozone in the stratosphere that keeps trapping this ultraviolet rays, such that these ultraviolet rays do not, or even if they will get to the surface of the earth, it will be in small quantity. Is that okay? Or say small measure, or say in less measure. Okay? And so this ozone actually helps us. That is how come I believe in JHS level you were taught that these refrigerators that we use, which emit this carbons, the CFCs, very bad. We have the motor rays, the exhaust, the smoke from the exhaust and all that. They go a long way to deplete, to destroy the ozone. And so we should be careful that we don't destroy the ozone. These industries that we have, then they'll be polluting the environment. This smoke will get into the space, get to the stratosphere, and gradually be destroying the ozone, be depleting the ozone. We need to be very careful because the ozone really helps us. It prevents the UV rays from reaching us, thereby causing us to have sunburns. Now, in fact, the ozone layer absorbs most of the UV radiation. That's the UV radiation the sun sends to us. Life as we know, it wouldn't be possible without this layer, okay, of protection. So the ozone layer really protects us. And as a result, temperatures rise as one moves upward through the stratosphere. You know, the troposphere, we said that as one goes up, the temperature reduces, it decreases. But in the case of the stratosphere, don't forget that the ozone is found in the stratosphere, and this ozone traps the ultraviolet radiation, kind of some of the sun's rays, okay? And because of that, we have the heat being suspended there, as in because of the ozone trapping this sunlight, which of course comes with ultraviolet radiation. We have this sunlight being suspended in the stratosphere. That is how come after one moving beyond the troposphere, temperature doesn't decrease again as far as altitude is concerned, but rather it increases. So in the stratosphere, there's a positive relationship between altitude and and temperature. The higher you go, the hotter it becomes in the stratosphere. But in the troposphere, the higher you go, the cooler it becomes. So in the troposphere, there is an inverse relationship, or in other words, a negative relationship between temperature and then altitude. But in the stratosphere, there's a positive relationship. All right. So let's make progress. Now, this is exactly the opposite of the behavior in the troposphere. Okay, exactly the opposite of the behavior in the troposphere, as I've just said, in which we live, where temperatures drop with increasing altitude, and the upper limit of the stratosphere is also called the stratopause. So the upper limit of the troposphere is tropopause, stratosphere to stratopause, mesosphere to mesopause, thermosphere to be thermopause, and in that order. Is that okay? I hope it's just simple and you are really enjoying the lesson. Now, this is an image or a picture of the stratosphere. So we have the ozone, okay? So these traces, this white picture that you see at the blue background, we have the maybe the ozone. In fact, it is the ozone, as we can see, ozone. And then we shouldn't also forget that we have some less amount of clouds over there. And so what you actually see here, this one which is very visible, is the ozone. This is what actually traps or what absorbs the ultraviolet radiation. I did not mean that like my skin, for instance, will be some way, yours too will be some way. And so the ozone layer really protects us. So just in case you are asked, in which of the layers of the atmosphere do we find the ozone or the ozone layer? That is the stratosphere. Okay, good. Now we are done with the stratosphere. Let's go to the mesosphere. The mesosphere is the third layer. Don't forget, we've learned about the troposphere as the first layer. Then the second layer is the stratosphere. And don't also forget about their altitude levels, also their height levels. Is that okay? The troposphere, averaging from the ground surface to the tropopause, is 18, maximum of about 20 kilometers from the ground. And then the stratosphere from 20 to 50 kilometers. So when you take the interval of the stratosphere, that is about 30. Is that okay? But the troposphere, don't forget that when we studied the other time, we talked about some variations. Okay? So some may just be, the upper limit may just be 12 kilometers from the ground, but it goes up to what? Maximum of 20 kilometers. And then we have the stratosphere also beginning from there to what? 50. So the interval of the stratosphere is what? 30 what? Kilometers. So from the 50 going to what do we have? Now our third layer is the what? Is the mesosphere. So let's study about the mesospheres too and see. So the mesosphere is the third layer, and it is directly above the stratosphere. So if it is directly above the stratosphere, then where do you think it will be? The upper limit of the stratosphere will be what? The stratopause. So the mesosphere is directly above the stratopause and below the thermosphere. So this statement or this sentence is giving a clue that the next layer after the mesosphere is the what? Is the thermosphere, because the mesosphere is lying below the thermosphere but above the stratosphere, or say the stratopause. Is that okay? Now, it extends from 50 to 85 kilometers, which is equivalent to 31 to 53 miles. So, you know, the stratosphere ends at 50 kilometers, or that is where we have the stratopause. Then from the stratopause to the mesosphere, we have 85. So it means that the mesosphere stretches for about what? 35 kilometers. 35 kilometers, which is equivalent to 31 to 53 miles above the earth. Within this layer, which layer are we talking of? The mesosphere. Within this layer, temperature decreases with increase in height. Temperature what? Decreases with increase in height. So, let's go back. Troposphere. Temperature decreases with increasing height, or temperature decreases when altitude what? Increases. So that's negative relationship. Then when we got to the stratosphere, we said that for the stratosphere, because we have some amount of sunlight being trapped in there, the heat is still there. We have some amount of heat over there. And so when one goes up in the stratosphere, temperature does not decrease. It's what? It increases. So there's a positive relationship between temperature and height, or temperature and altitude in the stratosphere. Here is the case that we are on the mesosphere. Okay? And here we are learning that in the mesosphere, as one goes up, the temperature what? Decreases, but it doesn't increase like in the stratosphere. So here temperature what? Drops. Temperature decreases as one assumes higher what? Altitude. And that is what we call positive what? Lapse rate. So there's a positive lapse rate in the troposphere as well, because the higher you go, the cooler it becomes. Is that okay? The higher you go, the cooler it becomes. So let me take it again. Within this layer, temperature decreases with increase in height, and that is what we term as positive lapse rate. And it is the coldest of all the layers. Did you hear that? The mesosphere is the coldest of all the layers. It is the coldest of all the layers. So as we move ahead, we learn about the temperature level over there. So it tells you that if it is the coldest, then it may even go to the negatives. Okay? Good. Now, you see, the temperature can be as low as negative degrees Celsius. Okay? As low as negative 90 degrees Celsius. Hey, negative 90. So in Ghana here, the fridges that we use, have you asked yourself the temperature? The fridges we use to preserve our foods so that we can consume them in later hours or in the future, in the near future, okay? Have you asked yourself the temperature level? Here we are talking about negative 90 degrees. Our normal body temperature is what? 37, right? 37 degrees what? Celsius. So if you take the measurement, if you use the thermometer and it drops like 35 degrees, 35 degrees, then you are sick, oh, you are sick. So imagine negative 90 degrees Celsius. What is equivalent to negative 130 degrees Fahrenheit, okay? The mesosphere and the stratosphere together are sometimes referred to as the middle atmosphere. Do you hear that? The middle atmosphere. The mesosphere and the stratosphere are sometimes referred to as what? The middle atmosphere. Does that mean that after the mesosphere, we have just one layer? Because after the troposphere, we have the stratosphere. The stratosphere, we have mesosphere. And we are saying that the stratosphere and the mesosphere are sometimes referred to as the middle what? Layers. Or the middle atmosphere. So is that to suggest that the remaining layer we are to learn is just one after the mesosphere? Let's move ahead and see. The mesosphere has some amount of clouds, but then it decreases with height. So the mesosphere also has some amount of what? Clouds. But as one moves up, as you go up, the amount of clouds or what? Decreases. Is that okay? Now, the meteors, okay, make it through the exosphere and thermosphere. Hey, we are hearing exosphere and thermosphere here. Okay, so it means we have about 2 layers more to learn. Okay? So we are saying the meteors make it through the exosphere and thermosphere without much trouble because those layers don't have much what? Air. And when we talk of the meteor, what is it? Meteors are parts of the other heavenly bodies that sometimes what? Come to the surface of the earth. They fall off from their original what? Location. If you have forgotten, just go back and then learn the planetary what? Learn the planetary system again. And this meteors, as it falls, okay, as it directs its way to the surface of the earth, as it passes through the exosphere, what is the outer space, okay, which separates the outer space from the atmosphere, it has no trouble. When we say it has no trouble, all that it means is that we don't have much air in the exosphere and that of the thermosphere. And so there's no that friction taking place between the meteor and its surrounding for it to start glowing. In other words, for it to start what? Burning. Okay? But the moment the meteor gets into the mesosphere, the stratosphere, then you will see it to be burning. And that is what we call what? The shooting one star. And sometimes you'll be there and it's like, oh, one star is falling, a star is falling. You see the starlight is falling. You get that? It's because because we have too much air in the atmosphere where the meteor has got into. There is that friction between the meteor and then the atmosphere. Is that okay? And then because of that, we have the meteor beginning to what? To glow. In other words, to burn. Is that okay? Good. So the meteors make it through the exosphere and the thermosphere without much trouble because those layers don't have much air. So when we get there, we'll talk about them as well. Now, however, when they hit the mesosphere, there are enough gases to cause friction and create heat, which can be termed as the shooting what? Star. And so we call it shooting star. And then the upper limit of the mesosphere is known as what? Mesopause. That I've told you already. You know, geography is very, very interesting. And so, as you find yourself on the surface of the earth, you know, this surrounding that we see ourselves, you know, we have layers. So people have been able to, researchers have been able to what? Study. And then we have divisions in the air. We have divisions in the atmosphere. We have layers. So we've learned about the troposphere in our previous lesson. This time around, we've looked at the stratosphere. We've looked at the mesosphere. Now, let's go to the third layer. And what do you think is the third layer? The thermosphere. Good. So there we are. Okay, before that, I think there's an image that we need to look at. You see the meteor. So once it gets into the mesosphere, because we have enough gases, there's friction. Friction is being created. Then the meteor begins to what? Begins to burn or begins to what? Glow. Then we see it as a falling star. And that is what we normally call what? Shooting what? Star. Okay. So thermosphere is the next layer. In fact, it is the fourth what? Layer, because the first one is troposphere, second one is stratosphere, third one mesosphere. So the thermosphere is the fourth layer. So let's see. This is the fourth layer which lies above the mesosphere and below the exosphere. So once we say below the exosphere, hey, there's a clue. It means that after the thermosphere, we are not done. We have another one called the exosphere. Good. It extends from about 90 kilometers, which is the same as 56 miles, to between 500 and 1,000 kilometers above the Earth's surface. Wow. So it tells you that this one too is not even what fixed. It keeps changing because I told you earlier that temperature plays a major role as far as the divisions of the atmosphere are concerned, or the layers of the atmosphere are concerned. So temperature really plays a role. In the troposphere, the higher you go, the cooler it becomes. In the stratosphere, the higher you go, the hotter it becomes. In the mesosphere, the higher you go, the cooler it becomes. Is that okay? So in the thermosphere, what can we see? What can we see? So let's make progress. Now, within this layer, which layer? The thermosphere. Good. Temperatures increase sharply in the lower thermosphere. It means just after the thermopause. Okay? Temperature increases what? Sharply. Then level off. The temperatures what? Level off. It means it becomes steady. And hold firmly steady with increasing altitude above 300 kilometers altitude. Solar activity strongly influences temperature in the thermosphere. Have you seen that? Solar activity, as in the activity of the sun, the sun's what? Rays. Okay? Strongly influences temperature in the thermosphere. Good. Now, the thermosphere is typically about 200 degrees Celsius, equivalent to 360 degrees Fahrenheit, hotter in the daytime. So it's like step by step. Higher you go, cooler it becomes. Higher you go, hotter it becomes. Higher you go, cooler it becomes. Higher you go, hotter it becomes. Are you getting it? Troposphere, stratosphere, mesosphere, thermosphere. Okay? The temperature as vis-a-vis the altitude keeps what? Changing. Good. Now, so the thermosphere is typically 200 degrees Celsius, hotter in the daytime than at night, and 500 degrees Celsius, equivalent to 900 degrees Fahrenheit, and beyond hotter. Let me take it again. The thermosphere is typically about 200 degrees Celsius, hotter in daytime than at night, and 500 degrees Celsius and beyond, hotter when the sun is very active. So it means even with this 500 degrees Celsius, when the sun is very active, we can have more than a 500 degrees Celsius. Temperatures in the upper thermosphere can range from about, 500 degrees Celsius to 2,000 degrees Celsius, or even higher. Can you withstand? So it means gradually you are drawing closer to the sun. Can you see that? Yes. 2,000 degrees Celsius or beyond. That is the thermosphere. Okay. Within this layer, there is absorption of ultraviolet radiation by atomic oxygen, hence temperature increasing with altitude. The notable gas in the thermosphere is hydrogen. Is that okay? Hydrogen, which has no direct meteorological significance. The light hydrogen predominates at higher levels. Is that okay? Good. Now, this layer, as in the thermosphere, we are still talking about the thermosphere. This layer comes under cosmic rays. And what is this cosmic rays? X-rays and ultraviolet rays or ultraviolet radiation at a distance above 150 kilometers. For X-rays, we all know, sometimes when you're having a fracture, a bone fracture, okay, you go for an X-ray. Let us know the extent of, damage. The extent of the extent to which the bone has broken. You go for an X-ray, okay? It can be your fingers or something. Then the doctor or the one in charge gets the image and then examines it and tell the extent to which things have gone. The cosmic rays, in fact, the difference is that the cosmic rays come with high energy levels. Is that okay? The energy is very high. And we're saying the thermosphere is home to the International Space Station as it orbits Earth. When we talk of the International Space Station, it's giving you a clue that that is where we have most of these artificial satellites. Is that okay? So most of these satellites are stationed in the thermosphere. And as we speak, if I'm not exaggerating, we have about 5,465 active satellites in space. Is that okay? And these satellites, it depends on the purpose or the purposes. Is that okay? We have satellites that are meant for communication purposes, satellites that are meant to observe the Earth and give information, satellites that are meant for technology development and demonstration. We have satellite for navigation and positioning. Is that okay? And in fact, with these satellites in space, more than 50% belongs to America. You see, you are mentioning NASA, National Aeronautical and Space Administration. About, I think 3,000 plus of these active artificial satellites belong to America. And all these satellites are being stationed in the thermosphere. That is how come you and I, if we should take the communication satellites into consideration, now we have what? Mobile phones. And with this mobile phone, you may have a relative on a different continent. Let's say you are in Ghana here, Africa here, and you have a relative in, say, America. You just pick the phone, you dial, and then you call, hello, mommy, I miss you. I'm in Ghana. The temperature in Ghana is quite high. I want to come to America, you know. Quite high, but we are enjoying it here. So that's just by the way. So that is it. And then we're saying the upper limit of the atmosphere is called thermopause. For this one, you know. When you take all the layers of the atmosphere, in fact, the upper limits are called, or say are defined by the name of the layer followed by a pause. So we have tropopause, we have a stratopause, we have mesopause, we have what? Thermopause. Is that okay? Good. Now, you see, this is an image on the screen for you. And then we said in the thermosphere we have some amount of clouds. So I want to believe that this green color that you see will be some of the clouds over there. And then you can see this particular object or say instrument over there. That is a satellite. In fact, it's an artificial satellite. So International Space Station. And don't forget that when it comes to the natural satellite of the Earth, it is only the moon. The Earth has just one satellite, and that is what? The moon. But aside that, we have been able to go into the thermosphere and fix. When I say we, don't get me wrong. I mean human beings. Okay? So we've been able to, install satellites in space. In other words, in the thermosphere. So, in case you are asked, which among the layers is seen or is accepted to be the station for satellites? That is the thermosphere. And once again, we have about 5,465 active artificial satellites in space. And it depends on the purpose of that particular satellite. It doesn't mean that all of them are for the same purpose. So just as I said, some are meant for communication, some to observe the Earth and then give information about how the Earth is behaving, some for technology, development and demonstration, some for navigation and position and all that. Is that okay? So maybe very soon Ghana, we should also be able to go to the thermosphere and then install our own satellites so that we can have the bragging rights. Is that okay? Good. Right. Okay, so it means we're done with the thermosphere. Let's look at the exosphere. The exosphere is the outermost layer of the Earth's atmosphere. Did you hear that? The exosphere is the outermost one layer of the atmosphere. So it means if we should take the atmosphere, the upper limits, or kind of before you go beyond the atmosphere, what we have is the what? Is the exosphere. Exo means outside. Okay? Exo means outside. Hence, it is the very edge of our atmosphere. So the very edge, kind of the upper limits. But this one, we don't call it what? Anyway, you let me just hold it right there. So So this layer separates the rest of the atmosphere from outer space. It's about 6,200 miles, equivalent to 10,000 kilometers thick, which means it is really, really big. The stretch of the exosphere from the thermosphere is very wide. So I wonder if someone will want to go into the exosphere and even go. What do you want? That's just by the way. Now, that means that for one to get to outer space, the person has to be very, very far from Earth. The exosphere has gases like hydrogen and helium, but no air to breathe, and it's very, very cold. So just in case you want to go to the exosphere, then please, for your information, there is no oxygen there. So prepare and go there. Right. Good. So this is an image of the exosphere on your screen. You see, darkened, and in fact, kudos. I doff my cap for the geographers, or say the astronauts risking their lives to get us information, and now we can use mobile phones and all that. For you, all that you know is that you go to the shop, you buy your phone, you get your SIM card, you slot it in, and you are good to go. Thumbs up to all those people. Now, ionosphere. You know, when I was touching on the objectives, I did underline the fourth objective, which was the exosphere to be explained. And I told that I will tell you why. All because the exosphere marks the outer limits of the atmosphere. And then when we talk of the ionosphere, what is it? The ionosphere is a very active part of the atmosphere which grows and shrinks. It grows and shrinks, depending on the energy it absorbs from the sun. In other words, the heat energy, so temperature, okay? Within this layer, atmospheric gases are ionized. And what does that mean? Thus, the gases are converted into ions. And these ions are electrically charged particles, which are conductors of electricity by incoming radiation. One time. Good. I don't have much time. It overlaps. That is the ionosphere. It overlaps the mesosphere, thermosphere, and exosphere. So kind of when we talk of the ionosphere, a portion of the exosphere, thermosphere, and the mesosphere. So the ionosphere is not actually a particular layer, but it overlaps. It grows and then it shrinks. Parts also overlap with Earth's magnetosphere. Is that okay? Which is the area around Earth where charged particles fill Earth's magnetic field. The ionosphere has practical importance because, among other functions, it influences radio propagation to distant places on Earth. I don't mean to cancel it, but to underline. Once again, the ionosphere, among other functions, it influences radio propagation to distant places on Earth. Is that okay? That's the ionosphere. Don't forget that the previous lesson, I made mention of sound zones, right? Yes, which I said it is an equipment that uses, in fact, we use balloon, okay? Balloon to carry that particular equipment to measure distances, okay? Good. Now, let's quickly look at the importance of atmospheric resources. What do you think are some of the importance of the atmosphere? Just name them. We have oxygen to breathe in and out. We get the sunlight. In fact, so many things. So quickly, number one, oxygen is used by plants and animals. Not so. It also supports combustion or burning. The ozone is important for protection against harmful radiation. I talked about it. Vitamin D, early morning when the sun begins shining. As I would say, the sun rises and the sun doesn't rise. Is that okay? It is the earth that rotates. And then at a point, you have the sunlight at one place, at another point, at another place. So go and revisit your previous lesson. So vitamin D is derived from sunlight, which helps in building and maintaining the strength of our bones. the strength of our bones. Is that okay? Then the sunlight rays also cure neonatal jaundice. So, I mean, we have a lot. Sunlight is important for photosynthesis. Water vapor moderates atmospheric temperature. Rainfall provides water for agricultural and domestic usage. Do we have again carbon dioxide aids in photosynthesis and also used for fighting fire outbreak. The solar energy and the wind are used for generation of electricity. Carbon dioxide absorbs heat to control atmosphere. A lot. Start jotting some. Start writing some of the importance of the atmosphere. Apart from what I have given you, you will get a lot. Is that okay? You will get a lot. So, my cherished learners, okay? I think, let's see whether we have more. Oh, okay. We also have human activities that negatively affect the atmosphere. Can you do something at where you are that can affect the atmosphere? The answer is a big yes. So what are some of these? Air pollution causing global warming and climate change. Air pollution. We have our motorists. Sometimes you see the amount of smoke that emits from the exhaust. Very serious. The industries, okay, emitting those smoke into the atmosphere. Release of exhaust fumes. Yes, it is even here. Release of exhaust fumes from automobiles and industries forming smog or smoke in the atmosphere is also another one. Discharge of chlorofluorocarbons from old refrigerators leading to greenhouse effects. Sometimes the fridges that we use in our homes making too much noise like that. The CFC that it emits, in fact, it goes a long way to emit the ozone layer or to emit the ozone, I must say, which protects us from the too much of the sunlight from the sun. Is that okay? To cause wrinkles of our skin and our sunburns and all that. Now, the next negative activity by humans that destroys or that affects the atmosphere is release of various chemicals from aerosprays such as deodorants, hair sprays, and insecticides, or say insect sprays by humans and so on. All these hair sprays that we use, the insecticide that we do, go a long way to deplete the ozone or to affect the atmosphere negative. Oh, so here we are. I thank you. I thank you so much for making time to follow me right on Joy Learning to kind of update ourselves, or if this is the first time, learn the layers of the atmosphere. Okay? And so in case you want to get a full version of this lesson, do well to watch that of the first one where we talked about the troposphere. And then this one, of course, we continue from the stratosphere. After the stratosphere, then we look at the mesosphere, the mesosphere, the thermosphere, the exosphere. We talked about the ionosphere, which is actually not a layer, but overlaps, okay? Overlaps between the exosphere, the thermosphere, the mesosphere. And we said that it shrinks and sometimes to what? It grows. Is that okay? Then we looked at the importance of atmospheric what? Resources. Oxygen, as you and I will breathe in. Is that okay? That is what we need to survive actually. And then we take the oxygen from the plants. The plants also take the carbon dioxide from us. This ozone protects us from direct contact with the ultraviolet radiation. And of course, we have satellites being installed in space which serve many purposes for communication-wise. The mobile phones that we use, even your television as you are sitting right there watching me on the screen. It's all because of satellites that we have, especially in the thermosphere called the International Space Station. And as I told you earlier, we have many satellites in space, but the greater part belonging to America. All right, so I think there's where we'll end the lesson. So please be careful you don't destroy the atmosphere with your, in quote, negative word activities. Once again, the name is Bogasam. Just in case you want to know where I am, come to Achimota School. I thank you so much. Have a wonderful time. Bye.
Subscribe to our YouTube channel, Joy Learning TV.